The universe extended indisputably, empowering out and out more first-rate length. After this period, it persevered to develop, however at a more languid expense. In the quit changing over into the universe we concentrate on as of late, that is the inflationary hypothesis of the collectible cosmic impact, the most prominent and generally saw speculation of how the universe began. Anyway, for a couple of physicists, this head theory does no longer precisely painting the develop of our universe. They recommended that the universe existed before that thing, stretching out endlessly into the past as well as into the future. Even as the universe is expanding these days, it became contracting ahead of time than the enormous detonation. In this view, the enormous detonation isn't really a bang as a jump. A second even while the contracting universe exchanged ways and headed out to make once more, as laid out through their hypothesis, the universe might have to sidestep with proceeded with improvement like less dissuaded by a breakdown inside the some distance future. Then another leap. A few physicists proposed the S may be endless. This horrible circumstance, the standard cosmological view in which the entire matter initiated with a huge bang, the first-class physicist Brian Cox, also difficult circumstances, the hypothesis of how things arrive to advance that something can't rise out of nothing. Adding to the stress, the James Webb Telescope has made alarming disclosures conflicting with the idea that the enormous detonation might be thought about the start of the universe. These discoveries convey up the inquiry if the huge explosion wasn't the start of the universe, then what should the universe in the long run start with a detour or something most certainly unmistakable? The idea that the universe had a start or an evening with no yesterday, as it became originally analyzed, gets back to George Lamra in 1927. Simultaneously, it's far a less than ideal circumstance to show that the universe probably had a start. That length of cosmic history has barely anything to do with the hot broad bang that portrayed our basic universe. However, exceptional area subject matter experts or even a minority of experts, regardless of the reality that live with conviction that the enormous bang denotes the earliest reference point of all that all matters considered. The definition is out of the enormous explosion isn't the introduction of life as we may be mindful of these days. In truth, there may be a ton of proof highlighted a non-singular start of our universe. We never showed up at those ends dependent generally upon no prominent endo or over-the-top temperatures. Our universe is great characterized by means of an inflationary length that occurred previously the huge explosion. The enormous detonation is the stop final result of what passed off inside the bearing of the culmination of progress. During improvement, the universe altered into most certainly void, no garbage independent of no F photons, just void region. Space itself became loaded with a gigantic amount of strength at each spot. This power changed after some time, reaching out in a fast and resolved design. Because the universe delayed, those adjustments relaxed to monstrous augmentations while new bound scale adjustments have been made to zenith them. This superposition of insecurities all through scales is a portraying component of cosmological expansion. It's for inconsistent reasons, not purpose. If you lived in an expanding universe, you may potentially find close by locals where an expansion arrived at an end or the region among you. What's more, them delayed persistently. In short, you could attempt to acquire what takes place nearer to the start of a huge effect before that area disappeared practically from view. It incorporates a little neighborhood local, taking all things together probability, no more prominent standard size than a human incredible hamster ball anyway, probably impressively bigger. The power capability of area then, at that point, gets changed over into be counted furthermore radiation. This change happens quickly, taking structure rapidly, yet not prompt because the energy shut up itself changes over into flume and some photons and more. The temperature rapidly expands from only a couple of degrees above outright Z to maybe around 20 Kelvin throughout the indistinguishable fast time period. Due to the enormous level of energy adjusted, all that activity is near the speed of gentle. All particles go about as radiation with colossal strength, whether massless or gigantic. This change is called warming, denoting the finish of progress, what's more, the beginning of the degree, alluded to as the new enormous bang. As progress continues, you'll witness a colossal substitute from all past circumstances. While the current enormous detonation starts, the expanding universe fast dials back. After the secret picture of progress in an inflationary universe spot expands absolutely, with more prominent and expanded way-away regions, strolling ceaselessly, even as progress closes, and the new enormous bang gets going. Advanced, more farther areas will subside from you to an always developing certificate. It continuously as time advances, the piece of the universe in which improvement closes sees the augmentation cost drop, while the expanding regions surrounding it see no such drop. Under augmentation, the space to any object should twofold after a particular length, and while that equivalent measure of time slips by, that distance duplicates once more endlessly. Once the huge explosion begins, this alterations, since the expanding universe eases back down after the underlying second of improvement. Before the enormous detonation, you may experience improvement clearing off with adjoining regions. Those areas wherein improvement closures will load up with antimatter and radiation and make greater more slowly than the as yet creating locals, leaving you in the expanding neighborhood. As a standard organization within spacetime, those areas in which intensity enormous bangs get up rise as far away from elite places where improvement keeps. Because of this, they'll expediently subside from one another's view. Inside the standard inflationary picture, because of this the improvement charge changes, there may be a little gamble that any universes with separate warm huge bangs will of all time cooperate. The area where we come to live gets rather fortunate, and improvement arrives at an end. For us, the power normal for space itself gets changed over to an intensity-thick and nearly uniform expanses of particles, with the number one blemish and furthermore takeoffs from consistency, concerning the quantum changes that existed and were relaxed across the universe. Faster or later of advancement, the high-quality energy quantum vacillations compare at first to overdense regions, while the awful energy vacillations get altered over into most importantly under regions. Those include as the seeds of huge structures. We can't see those thickness vacillations lately as they had been even as the universe most importantly went by means of the intensity huge explosion. There are not any noticeable engravings we can get admission to from that early span subsequent to going through extra affiliations. In spite of the fact that we can extrapolate back to figure out the underlying thickness vacillations, tracking down something consistent with the story of cosmic improvement. The temperature vacillations are engraved inside the inestimable microwave record, CMB, presenting proof of how the enormous detonation began. Yet there are different irregularities. Most of the CMB and our cutting-edge form of cosmology. We're missing something, and individuals can be summed up in 4 irregularities. First, on chiefly tremendous scales, the universe isn't generally acting as anticipated. The light from the CMBB is being lensed by means of our Among Us and the CMBB. That means depend behaves like an enormous focal point, bending and changing over the plentifulness of the gentle in the return of it. The volume of this lensing isn't continuously predictable with our bleeding-edge model, addressing a high-quality mission for cosmology. Besides, the different sides of the equator of the CMB sky have one-of-a-kind normal temperatures, clashing with the assumption for consistency inside the universe's earliest degree. The possibility that the universe should have begun dependably results in various irregularities. Third, the expense of the Hubble consistent, which depicts how fast the universe is expanding, changes contingent on whether we degree it from the astronomical microwave noteworthy past CMBB or from neighboring stars. All in all, those abnormalities propose we are inadequate with regards to something fundamental by the way we decipher the universe. One proposed arrangement comes from circle quantum cosmology, which starts from circle quantum gravity on the structure GRA. Gravity itself is made up of particles alluded to as quant, forming the texture of life in circle quantum cosmology. There's a littlest size of spot, the board scale, or 1.0 by 10^35. This approach implies the enormous bang couldn't exist in a universe depicted through this rule. As an alternative, the universe should by no means come to a limitlessly little dense issue, close to the huge explosion in circle quantum cosmology. While the universe became tiny quantum rectifications and anticipated a frightful strain causing a leap on the other hand of a peculiarity, this shows that our universe might have begun from a first universe that contracted after which broadened all over again, similar to a phoenix rising from the cinders. While the idea of an enormous skip isn't absolutely new, all the time, circle quantum cosmology gives a numerical structure to help its cyclic time. Very much like the possibility of a grandiose jump, it is moreover situated in who cosmology, including in basically the same manner way to this thought. If circle quantum cosmology is right, the early universe may have had a gentle energy and thickness. This current circumstance ought to alter the CMB, showing up as gentle varieties in temperature all through the sky. These varieties, measured through the quality energy range, ought to offer enormous proof of the universe's establishment, further guiding the chance of a leap. Ordinary circle quantum cosmology offers a convincing and open door to the ultramodern huge explosion variant, possibly settling a portion of the drawn-out status irregularities in cosmology and providing bits of knowledge into the beginnings of the universe. It, besides, gives a promising reason for the third and anomaly, the disparity in normal temperatures among the two halves of the globe of the CMB sky. The design gave with the guide of the method of circle quantum cosmology tends to the fundamental oddities situated in the CMBB, the surprising way of behaving at huge scopes, and the lensing impact in sync with Dr. Vanetko of the Public Organization of High-Level Examinations. The open door that those anomalies are not simply length blunders but start from quantum gravity results right off the bat in the universe is a remarkable thought. That the universe started out in a vast leap has been proposed previously, yet its insistence requires further exploration. Vast fluctuation represents an endeavor in this view, as our perceptions might be restricted to specific parts of the universe, confounding our insight. Specialist Dwayne Johnson, a coist of a giant look at and a professor at Ten Realm College, highlights the difficulty in approving such speculations because of the large scale. However, the incorporation of late open doors like circle quantum cosmology and its ramifications protects the guarantee in settling novel cosmological issues. Notwithstanding these updates, a gigantic inquiry remains. Did the universe have a start by any means? Defenders of the universe having a beginning demand that it did. However, this brings up issues about the nature of the occasion that started out everything. On the other hand, cyclic cosmology suggests an everlasting universe constantly present approach grandiose bobs. However, physicist William Kenny of the school at Bison recognizes the fundamental blemish in this idea: entropy. Entropy, the level of disorder in a system, increases with each cycle in cyclic cosmology. This increase implies a beginning to a Big Bang, conflicting with the notion of an eternal universe. The universe unquestionably expanded at an accelerated rate initially, continuing to grow but at a slower pace later, eventually evolving into the universe we know today. This is encapsulated in the inflationary hypothesis, the most widely accepted theory of the universe's origin. However, some physicists argue that this theory doesn't accurately describe the universe's evolution. They suggest that the universe existed before the Big Bang, stretching infinitely into both the past and the future. While the universe is expanding today, they propose it was contracting before the Big Bang. In their view, the Big Bang wasn't a singular event but rather a transition point when the contracting universe reversed course to expand again. According to this hypothesis, the universe could avoid a singular beginning and instead continue to evolve indefinitely, less hindered by a collapse in the distant future. Brian Cox, a prominent physicist, challenges the idea that things arise from nothing, complicating the traditional view that all matter originated with the Big Bang. Moreover, recent discoveries by the James Webb Telescope cast doubt on the notion that the Big Bang marks the universe's beginning. These findings raise the question: if not the Big Bang, what did mark the beginning of the universe? The concept that the universe had a beginning or a moment with no preceding time was first proposed by Georges Lemaitre in 1927. It's challenging to prove definitively that the universe had a beginning, especially since much of cosmic history is unrelated to the hot Big Bang that defined our observable universe. While many astronomers and a minority of experts still believe in the Big Bang theory as the origin of everything, its definition isn't synonymous with the origin of life as we know it today. Evidence increasingly suggests a non-singular beginning for our universe, not necessarily tied to extreme temperatures or high densities. Our universe is characterized by an inflationary period preceding the Big Bang. The Big Bang is the culmination of events during this inflationary phase when the universe became essentially void of matter, radiation, and even photons. Space itself was filled with immense energy uniformly distributed everywhere. Over time, this energy changed, expanding rapidly and consistently. As the universe continued these changes, they slowed to significant extents, creating new, measurable changes on a grand scale. Accelerated.